Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to finally run some of these programs that I've been promising we would in previous videos. So first thing we want to do is we want to fire up GDB. We will set our disassemble flavor to Intel. And now, in order to get some useful information out of our program as we run it, we're going to want to set some breakpoints. So that's the first thing we want to do. So if I disassemble main, I can see a couple of places I might want to set a breakpoint. Now, you can either set a breakpoint using an address or a function name. If you use a function name, it will set the breakpoint just inside the function. So I'll go ahead and do that, and I'll say break main, and it tells me that the breakpoint has been set. If I want to get information on my breakpoints, I just type info break. Again, if you have not gone through that GDB tutorial, I definitely recommend that you do so now. There are a lot of great tips in that tutorial, and I'm just hitting the highlights here. Great, so we have a breakpoint. How do we run our program? We run our program by typing run, followed by any command line arguments. In this case, there aren't any. Starts the program. It runs up to that point in main. If I type disas, it will show me the disassembly in context. Here I am. I'm just inside my function, and we've talked about what's going on here before. So here, you have a bunch of stuff that's being stored on the stack. So first, 88 bytes are allocated, then things are moved onto the stack, and then here we have our first function call to end malloc. Now recall that for 64-bit Linux, a lot of these parameters are passed in registers, not on the stack, as you might be used to seeing. So here I'm moving the value hex 100 or 256 into EDI and then calling end malloc. Now, in order to run things, we saw how to start them. We can continue to run them with cont for continue, or you can also type out continue if you like, or we can step through our program. To step through a program, you can use step I to step through an assembly instruction, because that's all we have. We don't have the C code, or next I. The difference between step I and next I is that if there is a function call, next I will call the function and return, whereas step I will step into the function. So if I look at this guy, he's at 400F80. I'm just going to go ahead and run step I till I get there. Now, there's command history in GDB, and there is also this feature. If I just hit enter, it repeats the last command. And here I'm stepping right along, and I should be right where I want to be. So if I type disas, you will see, sure enough, this is where I've gotten to. All right, now there's not a huge advantage to running GDB and stepping through stuff over just disassembling your program, other than the fact that this will show you the flow of the program. The biggest advantage is you can actually examine things. So I can use the examine command to look at various items. In addition, I can use info registers to look at registers. So here, for example, I could type info registers. I can look at the RDI register, which currently holds 1. If I do a step I, rerun info registers, I see that it now holds hex 100 or 256. So that's the registers. What about other things? If I want to look at other things, I use examine, which is simply X. It's not examine because you use it all the time, and it would be very annoying if you had to type out the word exam. followed by a slash, an optional quantity specifier, such as this, 20, and then I have to say, what do I want? I want to display in hex giants, please. Giants are 8-byte values or 64-bit values. I would like to display 20 of these at the stack. So I want to see part of my stack. And here it is. Here are some various values stored on my stack. Notice I used the $sign for my stack. And that's very convenient. There are some other popular format specifiers, such as S for string, and I could use that as well. So for example, if I just wanted to know about the RSI register, I could display it like so. Same thing with RDI. It's telling me it cannot access the memory at address 100, but that was the address that was stored. Rather, that was the value that was stored there. So back to our program. We're getting ready to call malloc. I'm going to go ahead and step over that with next I. I'm back in main. I can call step I, call that again, and because I don't have source code for put car, I'm just going to call next I, call it again, and I can see where I'm at. I'm ready to call popen, and first I'm going to move into EDI this value. So let me have a look at that. I'm going to do another step, and now I'm going to examine as a string RD, and that string was Python -- version. So this is being sent to popen. This is the command that's being sent. Let's go ahead and step over this until we get down here. Let's see what happens. Now we are ready to either jump ahead down here, or we're going to call this code. So we've made it past this test, and once again, we're setting up some values for another function call, fgets. So I'm going to go ahead and set a breakpoint at 400 FC2. Rather, I'm going to fat finger it, and then I'm going to do it correctly by putting a star first. Continue. Next I. And here we'll see what our return value looked like. And go ahead and call next I a couple more times till we get down to D3. Here we are. We'll look at our registers. We see that RAX returned 0 from the stir. So things are going well with our little process here, because if you look, it's getting set up to call daemonize. So it's going to start the daemon in the background. And if we do a little bit more disassembly, we'll see that this function is almost over. It's going to call that. It's going to write the process ID to a file. And it's going to do some logging. It's going to set up the sockets, etc. So I'm not going to bore you by tracing through this entire function. I just wanted to show you a little bit how you could look into this function and actually step through it if you weren't quite clear as to how the flow of this program goes. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.